Rahim. Assalamu alaikum dear students. This is our next problem having been chosen from the same book, Modern Physics by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay, a spacecraft traveling out of the solar system at a speed of 0.95 c, where c is speed of light, 3.0 into 10 to power 8 meter per second, sometimes taken as 2.998 into 10 to power 8 meter per second, sends back information at a rate of 1400 kilohertz. Okay, dear students, hertz, unit of hertz are second inverse. Okay, 1 over second is equal to hertz. Okay, kilo meaning for 10 to power 3. At what rate do we receive the information? Okay, two things are given. Speed 0.95 c, that is to say 95% of the speed of light, and other frequency is given 1400 kilohertz, and we have to find out the rate. Do we receive the information? Okay, now we are going toward its solution, but before starting our solution in a proper manner, we will have to introduce a few snapshots which will develop a foundation regarding the solution of our problem. Okay, these snapshots have been chosen from different books. This first snapshot is definitely chosen from the book University Physics by Young Friedman, while other snapshots have been taken from some other book. Okay, dear students, because we have discussed these snapshots several times in our previous problems, so here we include these snapshots in our problem, but we do not give any time for their explanation. Okay, so we are going to skip these 4 snapshots, okay, which have been discussed in previous problems in detail. Okay, now we are coming to its solution in a formal manner. Okay, using f over f naught equal to 1 minus beta under root over 1 plus beta under root. Here beta is speed parameter v over c. Okay, put v equal to 0.95 c, where c is speed of light. So v equal to 0.95 c can be considered as about 95% of the speed of light. Okay, from here we can write as v over c equal to 0.95. that is to say we have shifted c on other side of equality, and we have gotten v over c equal to 0.95, and we know that v over c is speed parameter, which is sometimes denoted by beta. Okay, so beta is equal to 0.95. Here, as per statement of the problem statement is of the nature that in this expression the value given, the frequency given, falls under the category of f naught, frequency naught. Okay, so we will put these two values in equation number 1, and our result will appear definitely. Okay, here f over 1400 kilohertz is equal to 1 minus 0.95 under root over 1 plus 0.95 under root. This implies that frequency f becomes equal to 1400 kilohertz into what we have done, we have shifted 1400 kilohertz on other side of equality, and after being shifted on other side of equality, this value from the denominator will be shifted to a numerator. Moreover, when we will subtract 0.95 from 1, we will get 0.05. Similarly, when we will add 0.95 in 1, we will get 1.95. Moreover, under root of 0.05 is equal to 0.224, while under root of 1.95 is equal to 1.396. Okay, so just simplification, no rocket science. After simplification, our frequency f becomes finally equal to 224.642 kilohertz. This is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.